A matrix is basically just a rectangular array of numbers. It kind of reminds me of like a spreadsheet. It's just a way to organize data, and we organize it in rows and columns. Now, some people get rows and columns confused. So think about for just a second, if you go to a concert and you're sitting in row 5, those rows go across, right? But if you think about some of the beautiful architecture downtown, you have the columns in the front of the building that go up and down that support the structure. So if you kind of visualize those two things in your mind, it might help you remember which are your rows and which are your columns. Okay, so we're going to give the order of the matrix, and it's going to be the number of its rows times the number of its columns. So if we look at this matrix, how many rows does it have? 3. And how many columns does it have? 4. So its order would be a 3 by 4. Now, every number in that matrix is called an entry, and we can represent each of those entries with a subscript. So the first number in the subscript tells you what row it's in, and the second number tells you what column it's in. All right, so we're looking for the number or the entry that is in row number 2 and column number 3. So what's in row 2 and column 3? 7, exactly. All right, so we can add, subtract, matrix multiply, and scalar multiply with our matrices. So those are the things that the operations that we want to look at. To begin with, 2 matrices are going to be equal to each other if they have the same order and all of the same elements or all of the same entries. So when they tell me that these first 2 matrices are equal to each other, then I automatically know that what's in the first row, first column in the first matrix has to be the same thing as what's in the first row, first column of the second matrix. So I know that X is equal to 3. So first row, first column equals first row, first column. So X is equal to 3. Then you can see 2 is equal to 2. And 3y minus 1 would have to be equal to what? 8. And then 5 is equal to 5. So if 3y minus 1 is equal to 8, then we would be able to solve that to figure out what y would be as well. Now, most of the time when they give you a matrix, they're going to use a capital letter for the matrix, and they're going to use like brackets around it for to designate that it's a matrix. So when I see something like what we've got down here in example 3, where we've got the capital A and we've got the brackets on it, we'll automatically know that that's a matrix. Okay? All right, now, matrices can only be added or subtracted if they have the exact same order. So if you have different orders, then we say that that sum is undefined. So it has to be exactly the same. It has to be a 3 by 4 and a 3 by 4, a 1 by 6 and a 1 by 6. They have to be identical. All right. So here they ask me to add A plus B. All right. So if I'm going to add A plus B, I'm going to take what's in the first row, first column, plus what's in the first row, first column, and I'm going to put it in the first row, first column. So I'm going to say 2 plus 2 is equal to 4. All right. Then I'm going to do the same thing, first row, second column. I'm going to take what's in the first row, second column, 2, plus first row, second column, 0. And that's going to give me my answer that goes in the first row, second column of 2. And we could keep right on going. So we could say, 4 plus 0 is equal to 4, and that finishes off that first row. And then for the next one, negative 3 plus 1 is negative 2. 0 plus negative 4 is negative 4. Negative 1 plus 3 is 2. You get the idea. Now, you do not have to show any work at all for this. I understand you can do that in your head. The only reason I have any work on here is it doesn't do you a whole lot of good for me to give you the question and then the answer, and not anything in between. If we were going to subtract, we would do the exact same thing, except for we would subtract. So we would say like 2 minus 2 is equal to 0 for the first row, first column. And 2 minus 0 is equal to 2. And 4 minus 0 is equal to 4. And that would be our first row. So adding and subtracting work the exact same way. All right, then the next thing that they give us is scalar multiplication. All right, scalar multiplication is literally when I multiply a matrix by a scale factor. So like in this case, I'm tripling it. I'm multiplying it by 3. So I'm literally going to go through and multiply each of those numbers by 3. So I'm just going to say 3 times 2 is 6. 3 times 2 is 6. 3 times 4 is 12. 3 times negative 3 is negative 9. 3 times 0 is 3. 3 times negative 1 is negative 3. You get the idea. All right. So that's how we're getting this new matrix over here. All right. So again, that's scalar multiplication. So then they'll start putting those things in combination. Like they might have us do scalar multiplication and addition or subtraction. All right. I got to follow order of operations there. So I would need to do my multiplication first. I would do the 3 times A. Now that's the one that we just did, right? That was that answer we just got. So let's go ahead and put that down here. That's 3A. And then we're going to subtract matrix B that they gave us up here at the top. All right. And so again, to subtract, we're just going to take what's in the first row, first column, minus what's in the first row, first column, put it in the first row, first column. So we're just going to say 6 minus 2 is 4. 6 minus 0 is 6. 12 minus 0 is 12. Negative 9 minus 1 is negative 10, and so on.